This is Module 3, Section 2 of Algebra 2. We're just going to review how to add, subtract, and how to multiply polynomials together. There were lots of rules that you learned in Algebra 1, so we're going to just quickly move through things and review them. Here we go. When you need to add polynomials here, adding two polynomials, like this is a trinomial plus another trinomial, the trick is that you just want to combine like terms. There's nothing else fancy about this. The parentheses only denote where the polynomial starts and ends. So for example, this is a trinomial plus another trinomial. So we can go ahead and combine the like terms. We have s squared terms. So if you take two of those and you add four more, what do you have? You have 6s squared. You don't add the exponents here when you're combining like terms. Now the rest of the problem, of course, we have some s's, -3 and +2 would be -1s, and then we have -5. So the answer would be 6s squared minus s minus 5. So we got a trinomial actually when we added those two trinomials. Let's try another. This problem can look kind of intimidating because of all the x squares and y's floating around, but again, you just want to isolate and find the like terms. So for example, we have a x squared y here, and we have an x squared y over here. So we can go ahead and combine those. -2x squared y, and then this guy is all by itself. It has no other like terms, so -xy squared, and then finally the numbers will combine to be +4. So -2x squared y minus x y squared plus 4. Quite a mouthful, but that's all you can do with this problem is combine the like terms. Let's look at subtraction. When subtracting polynomials, here we have a trinomial minus a 4-term polynomial. The only trick is to remember to distribute the minus sign on the second polynomial. So we need to change all the signs on the second polynomial. So you can also think of this as a -1 being multiplied into the entire second polynomial. So let's go ahead and get rid of all the parentheses by distributing that minus sign. So in blue, I have distributed all the minus signs, which changed all the signs on that second polynomial, and now you simply combine the like terms. Now you just combine the like terms. And you can see I took the 2 and the -1, made 1a to the third. This term was all by itself, so I rewrote it here. And then we had an a term here and here, and -5 and -3 makes -8a. And then finally, we had a +7 and a -7, and that added up to 0. So I just didn't write anything here. So there would be the answer. All right, let's move on. That's how you subtract. Distribute that minus sign. Now to multiply monomials, so just single term times single term, the rule is that you add the exponents when you multiply. You learned that when you learned all about how to multiply exponents in Algebra 1. We're going to add the exponents up as we multiply. And literally, that's all you need to do here. 7 times -4 is -28. The base stays the same, it stays y. And then you add 2 and 5 because you have 7 factors of y floating around in this problem. So there's your answer. That's how you multiply two monomials. Let's look at another example. And I would suggest you pause the video and give this a try yourself. First thing I like to do to help myself out, to get myself started, is I write all the bases that are floating around in this problem first. And then I go back and I look at the coefficients here. Negative times a positive is going to make a negative answer. And then I look at the numbers. 1 times 10 is 10. So sign first, number later is often how I think about that. Now I'm going to analyze all the exponents. I have 2 factors of a here and 1 here. So what number do I need to put there? If I have 2 here and 1 here, I'm going to need a 3 on that exponent. Now b's, there are 4 factors of b floating around in this problem, and then there are 13 factors of c there. Again, you're adding the exponents. There's an invisible 1. 1 plus 12 makes the 13. Okay, let's move on. When you have a monomial and you need to multiply that into a trinomial or binomial or anything, all we're going to do is the distributive property. So we're going to launch our missiles here and multiply as we go. And I want you to remember, when you take an x times an x, you get x squared. Only when you multiply two x's do you get an x squared. 4 times 3 is 12, and then 4x times -2 is negative 8x. We had an x that was being multiplied in also. Let's try another example, and you can give it a try yourself, and I'll pause. You just pause the video for a second and write your answer, and then you can check it. All right, let's see how you did. So you're multiplying a negative y into this, so you're going to get here, you're going to get negative 4y to the third, and then on the next multiplication problem, you're going to get negative 2y squared, and then on the last one, plus 3y. So check your answer. Hopefully you got that right. Let's move on. Now you know how to multiply a monomial into a binomial. When you multiply two binomials together, this is when the FOIL method comes into play. Now I have another video that goes into the FOIL method in depth, but let's just go ahead and review here. You take these two things and you multiply them. And then you take the outside and you multiply them. And then you take the inside terms and you multiply them. And then you take the last terms and you multiply them. Notice I said the word multiply 4 times. So this was F-O-I-L. And that's how you get your 4 terms. And then in the end, you usually can combine the middle terms. Not always, but usually. And that would be your final answer. It happens to be a trinomial because we got a middle term. Now here's a bunch of FOIL problems for you to try. And in fact, the third one there is a FOIL problem because if you write this out, it would be 2 factors of 2x minus 1. So if that helps, you can write it that way and then you can FOIL it out. And then this one in the upper right corner is special because it's called a sum and difference pattern. So I'd like you to try these 4 problems and then check your work. I'll put the answers up here in a moment. And there's the 4 answers for you to check your work. Notice down here, when you square a binomial, you always get a middle term. Always, always, always when you square a binomial. So don't forget that because it's actually a foiling question in disguise. Now up here, this one's a little different. This is called a sum and difference pattern. So what happens is you get 5x and negative 5x, and they actually add up to 0x. So in this case, there is no middle term. So when you have a sum and difference pattern, no middle term. When you're squaring a binomial, you definitely get a middle term. The last problems we're going to deal with here today involve typically a binomial being multiplied into a trinomial. And there's a couple different ways to organize your work, but probably the most efficient way to do it is to just think about this as being a positive a, and you need to multiply it against all 3 things. So a to the third plus 3a squared minus 4a. And then we're going to change colors here so that it jumps out. Now we take the positive 2 and we multiply it all against all 3 things. So we end up having to do 6 multiplication problems here. 2a squared plus 6a minus 8. And now we're going to combine our like terms. So we have some a's that are like terms, and we also have some a squares that turn out to be like terms. So let's write our final answer then. We get a to the third plus 5a squared plus 2a minus 8. And notice how I wrote that in standard form. I wrote the biggest exponent first, then the next biggest, and the next biggest. And it's just nice. That way we all write our answers the same way. All right, we have one more problem to fly through. On this question, we are going to cube a binomial, not square it. We're going to cube it. Now, here is the common mistake, is to write this as the answer. You see, I cubed the 2 different things, but that would be wrong. You don't want to do that. Instead, what you need to do is think about it this way. 2x minus 1, 2x minus 1, and another 2x minus 1. And then you go ahead and you FOIL out the first 2, and you get 4x squared minus 4 plus 1. And then in part 2, you are going to do it just like we did on the previous slide. Take that 2x and multiply, multiply, multiply. Looks like I lost an x there. So we end up getting 8x to the third minus 8x squared plus 2x. And then we take the minus 1 and we multiply it in on all 3 things. So we end up getting minus 4x squared plus 4x minus 1. Hopefully I didn't make some silly goof as I'm trying to go quickly here. And our final answer when we combine like terms would be 8x to the third minus 12x squared plus 6x minus 1. So very different answer from what we had over here, because that would be the wrong way to do this. You actually have quite a bit of work to do. It's not difficult. You just have to organize your work, and then you'll be successful here. Okay, hopefully you now are aware how to add and subtract polynomials, and then you can also multiply any polynomial against another with all the skills that we talked about today. All right, good luck.